Welcome to Brain Vision.
For this question, we have the CD-ROM acting as a diffraction grating with slit size of about 1.6 micrometers. So for a diffraction grating, the equation for the maximum intensities is the sine theta equals to n lambda, right, where n is the order of the maximum, lambda is the wavelength that we are looking at, d is the slit size, and theta is the angle from the normal. Right. So in this case, we are looking at electrons with velocity of 1.26 times 10 power 4. To find the wavelength, we use de Broglie's wavelength formula. That's h over p is h over m times v. From here, we can then find what is the angles, right, for the various maximums. So we want maximum to be at the first order and the second order maximum. Go from here, that's theta is equals to log sine of n lambda over d. So theta 1 is just when n equals to 1. This will be just lambda over 1.6 times 10 power minus 6 meters. So substituting this value over here, should get theta 1 to be about 2.07 degrees. Sorry, this is sine inverse, right? Don't forget the sine inverse or arc sine. For theta 2, it's just sine inverse of 2 times of lambda divided by 1.6 times 10 power minus 6. And this should give us about 4.14 degrees. Now we know that this CD, right, the diffraction from the CD ends up on a film, right, behind with a distance of 50 centimeters from the CD itself. We want to find what is this distance, right, between the maximum, right, where this is the first order and equals to 1, and this is the and equals to 2. So how do you find this distance? Well, we know the angle, right, theta 1 and theta 2. We can use the tangent formula. So let us call this y1 and call this y2. So y1 must be equals to tangent theta 1 times 50 centimeters. This should give us about 1.81 centimeters. y2 is equals to 50 centimeters times tangent theta 2. Theta 2 equals to 4.14, right? So this should give us approximately 0.5 centimeters. Therefore, the distance between them, which is just y2 minus y1, should give us about 1.81.